If you are here to look for how you can create pipelines, CI and CD pipelines for your mobile applications, for your web applications, and for your containerized applications using Azure DevOps with Azure Pipelines feature, then you are in the right session. Good morning, everyone. Thank you for coming to my session today to learn how we can create those different CI/CD pipelines using Azure DevOps. My name is Hossein Delai. I'm a Microsoft MVP, and I'm focusing on cloud and DevOps tools. The plan for my presentation today will have lots of demos for those three scenarios: mobile, web, and containerized applications. And we'll explore the different options available with Azure DevOps, like the usage of the private agent, the integration with third-party applications, and also we'll see the configuration as code and how we can use and deploy applications into Azure. So we'll have lots of demos. But let's start with the basics of DevOps. So we'll have our developers working with the ops and with the DBA to commit their code into, let's say, one repository where we have the code for the application, for the infrastructure, and for the database. They'll commit this code into Git repository. This could be GitHub or Azure repo. And in every commit to GitHub, we want to create a build so that we generate a package. And during this build, what we want to do is not just generating the package, but make sure this package doesn't have bugs or doesn't have anomalies. For that, it's important to run some unit tests or maybe also some integration tests to make sure this package is safe to be deployed. So the goal of the build pipeline is to generate this package. During the CD pipeline, we'll take this package, then we'll deploy it into our server. This could be on cloud, on-premise, or whatever you choose. And when we say deployment, here is not only deploying the application, but if I have a database, then I should also deploy the database, deploy the new schema for the database. And here maybe I want to create some temporary environments using the ARM templates. So here the deployment, it goes for the ARM template for deploying the infrastructure, deploying the application, then deploying the DBA. And of course, we need to not forget about the monitoring and improvement so that we enhance our DevOps process. Our tool for today is Azure DevOps. And maybe you know some other tools like Jenkins, TeamCity, Circle CI, or whatever tool you are using. For today, this demo will be focusing on Azure DevOps. With Azure DevOps, we can create those CI/CD pipelines, but also we can have this feature called Azure Board for agile planning, where you can add your developers and create user stories and tasks. Then we have another feature, Azure Repo. This is the equivalent of GitHub, where you have a Git server installed. And you get that out of the box, where you can put your source code. We have also Azure Test Plans. Azure Test Plans is the features that allows you to run tests and see what tests successfully runs and what are the tests that fails. Those could be functional tests. Also, we have another feature in Azure DevOps, which is Azure Artifacts. Here, using this feature, you can save your NuGet packages, your Maven packages, npm packages, or whatever are dependencies for your application. Today, we'll be focusing on Azure Pipelines. So let's start with the demos. I'll go exit. So how many here are Java developers? Java developers? Just 3 in the room? Okay. How many are .NET developers? Here we go. JavaScript or Node.js or JS frameworks developers? Okay, quite a few. Go developers? Go. One developer uses Go. Okay. So we'll start our demos with Java application. Then we'll move to .NET. So we are coming to .NET. Let me start here with my Java application. Let me show you what this application do. So this is basically simple Java application that uses Spring Boot, and it have a basic controller that just shows this message, greetings from Spring Boot. I have also one unit test for this application that will invoke that endpoint, make sure that the response is okay, then compares the response to the one it should return by the page. So I have web app and unit test, and now I want to create the CI/CD pipelines for this application. So as we saw in the presentation, the CI/CD should start by first phase, which is deploying the application into a repository. For that, here I have pushed the application into GitHub, and so that from the CI pipeline I can get this application from here. To start with, I have already created Azure DevOps account. You can do that for free, and I have created a project to start my demo. And from here, we have the different options for Azure DevOps. And here we'll be focusing on Azure Pipelines, builds, and releases. So let's start with the build. Let's click on build here to create a new one. And you see that here I have already created some builds before. And now I'm going to create a new one to see how that experience looks like. So let's create a new build pipeline. And here, first thing, it will ask me from where I can get the source code for your application. Here it supports multiple sources like GitHub, Azure Repo itself, Subversion, or whatever Git server you use. Here our application is on GitHub. For that, I select GitHub. And from here, you see that it tells me that I'm already authorized because I have done that before. But the first time you see this window, you will have a button, call it connect. You click on it, you will have a pop-up. It will ask you for your login and password. With that, Azure DevOps will connect to your GitHub account so that it can retrieve all the repositories you have there. So now I'm connected. Now I can select one of my GitHub projects. I'll go here and look for this Spring Boot project. And here it is. I selected. Now I have selected the project. Now maybe I have different branches in my application. I have dev, test, or dev, fix, release, and master. Here I continue with master for this demo. Then I click continue. After that, we'll have here those two options for either using the YAML configuration files. We'll see that in a moment, but let's start simply with those visual tasks. So here, Azure DevOps provides some templates for my application. So it tells me if you have a .NET application, then we have here, we have provided some templates, complete templates for your .NET application, whether it is .NET Framework or .NET Core. If you are using Android, then we have the right template for you. And the same if you are using Docker, we have the tasks for Docker. You have for Python, for Xamarin, for NodeJs, and so on. And you can, of course, create your own customized pipeline. Here we have a Java application. With Java, we can build either with Maven or with Gradle. We have both options here, but here I continue with Maven. I select Maven. Then from here, we have different steps that we need to configure. The first one is to specify the agent that we want to use right here. So let me show you here. We have different agents. So first of all, we have different agents that can run on different virtual machines. Those agents are like the controller and other CI/CD tools. And those agents will run inside a virtual machine, and they will use the programs installed in the virtual machine to run the pipeline. This means if here I have a Java application, I need the Java runtime and the Java SDK to be installed on that virtual machine. For that here we have different virtual machines. So now if you have iOS application, I only can build iOS applications on macOS. For that I have a macOS machine. And for that reason we have different OS or different virtual machines depending on the requirement of your application. Here we have Java application. We can build it on iOS and on macOS, Windows, or Linux, whatever. And for each of those agents, each of them have different programs that are installed. We can view those installed programs if we click here on Pull Information. This will give us this list of the programs that are available on this machine. So we see here we have Ansible, for example, we have Azure CLI, we have the Docker installed, we have the .NET Core, we have .NET Framework, of course, and we also have the environment for Android SDK and so on. And of course, we have Java installed right here. Let me look for Java. So we have the Java, different versions of Java installed, and also we have Maven also installed in this on this VM. You notice that also we have for Windows we have different agents. This first one, hosted, uses the Visual Studio 2015. So everything that comes with Visual Studio 2015 will be installed on that VM. If you require to use VS 2017, then you have an agent for it. If you use 2019, then you have the agent for it. We have also, if you use Docker containers for Windows containers, then we have a hosted agent for this need. So here we have two different families. We have the hosted agents and we have the private agents. What are the difference between the two? So the hosted agents are provided by Azure DevOps. Azure DevOps provides you these agents and tells you can use them for free. Those agents are configured by Azure DevOps. So it only have the list of the programs installed on it, the list that we saw earlier. And we have the private agents. Those agents, I have created them myself. So I have my own virtual machine. I have installed the agent. And why I might need this private agent? We have mainly two reasons. The first one is to accelerate the build time through using the cache. For example, with the hosted agent, in each time we run the build, it will go and restore the entire NuGet packages or Maven packages, and it will get all the files from my repository. The same if I build a Docker container, it will build from the first step. It won't use the cached or the layered cache generated by Docker. So we can accelerate the build time by using the cache. For today, it works like this, but now Azure Pipelines team, they are working on a feature to enable using the cache with those hosted agents. So we might see some improvement in performance later. But a second reason we might use the private agents is to install whatever software you want, because it's your own VM. So you are controlling it, and it's your agent. So you can configure your VM to install some tools that are developed only by you, for example. So we have more control over those private agents. Here we'll continue with this hosted Ubuntu 16.04 machine. And now we have another. So now we have choose the agent that will run the pipeline. Now we need to choose or to configure this pipeline to get the right pom.xml file. This one will be used by the Java application. This file contains the configuration for how to build the Java application and how to run the unit tests. So we need to specify the location for this file. Here, this template, by default, it thinks that this file will be in the root directory for my repository, but it's not in the root directory. So I can click here, this button, to say where it can find this file. It's inside the app folder in my case, and it is right here. So I select it, click OK, and here it updated its location. After that, so we have already configured from where to get the source code for my application from GitHub. Then to configure the agent, if we, and you see here the demands, it will look for Maven. So Maven should be installed on that agent. So here, this pipeline will configure some check to see if Maven is installed on that VM. If it's not installed, it will tell me that, hey, you don't have this requirement installed on that VM. After that, we'll start running the CI pipeline itself. And the CI pipeline here, it have only this one main task, Maven. With this task, it will run the command Maven package in order to generate the jar package and also to run the unit tests. Here we have some configurations we can make with Maven. For example, we can tell it, when it runs the unit test, we can tell it to publish the results into an XML file. So it will do that, and it will put the results in this file right here. We can also perform some code coverage, and here we have we can use two tools integrated in this pipeline. We can use either Kubernetes or JCoco. Here I'll choose Kubernetes, for example, and we have some other options to configure. So the role of this task is to generate the jar file. That's going to be the package we need from our CD pipeline in order to deploy it into Azure or into any application server you use. Now, the CI pipelines and the CD pipelines might run on different agents, on different VMs. So we need a way to pass the jar from the CI pipeline into the CD pipeline. For that, here we'll be using this concept of artifact. The artifact will be accessible from the build and the release. So to use this artifact, we'll copy this jar file generated by the Maven, and we'll publish it into this artifact, into a drop folder, so that we can access it later from the CD pipeline. So this is our CI pipeline. Now it's ready through this template. Now we can save it and queue it to run it. So I'll click Save and Queue. And now my CI pipeline will start running. Here it gives me a URL where I can view the log files to see if we have some errors. Here it starts by looking for an available agent to run my pipeline, because this is a list of agents available on Azure. So now it gets one, it will initialize it, it will get the script that runs the CI pipeline. And it will start by performing checkout for my code from GitHub. For that, we can see that here we have some configuration for GitHub. Git remote add, so it will get this application from my Git repository. Then it will start running the Maven task, where here it is generating, it will start by restoring the Maven packages or the dependencies needed for my application. Then it will generate the jar file. Then it will run the unit tests. It will perform the code coverage, and it will publish those test results into the artifact. And this should take just a few seconds. We can see here the evolution in this console. And if everything goes wrong, then we can see the error will be displayed immediately. So this is running in real time from the agent. So now it finished running the Maven task, it published the test results, and now it copies the files and will publish them into the artifact. So this is all for this pipeline. And now all our tasks run it successfully in 1 minute and 31 seconds. with this, what we get in the summary is that we get the artifacts that we have created. And the artifacts here, they contains two files. The first one is the drop folder. This one should contain our jar package. So if I expand it to target, here I can see this the jar file generated by the CI pipeline. But we see another folder right here, which is the code coverage report. This one will contain the generated files from the code coverage tool, which give me more details about the coverage for my application. Here we can see that coverage displayed here in this menu. It tells me here I have 100% lines coverage, because here I have only one unit test, so it's simple to have 100%. Then we can see the results for running the unit tests from this window right here. It tells me I have one unit test, it passes successfully, and the coverage is 100%. So my build pipeline ran successfully, and from here I can see this pipeline were triggered after a commit on GitHub. And it gives me here the right commit on GitHub. If you see the URL displayed at the bottom, you can see this will point me to the right commit in GitHub, so that I can see which thing triggers the build for this pipeline. So this is for the first option, where we used the template, the visual representation of this pipeline. But with configuration as code, we can export this pipeline into a YAML file. This is like your Jenkins file. We can do the same in Azure pipelines. So we can export those files. We can export it by selecting, like, for example, here, agent, and click here, view YAML. This is what it uses to run the pipeline. So this is the YAML configuration for the pipeline we saw. We can get this YAML file and include it in our repository. That's what I have done here. I have added that YAML file into the application's source code. So we see here almost we have the same steps. It tells this pipeline should run on this Ubuntu agent. It should run the Maven task. It should copy the files, then should publish them into an artifact into the drop folder. So with this, we can version control the configuration of the pipeline. So each time if we have another requirement for the application, we can update it at the same time with this YAML configuration file. So we can now we can run the CI pipeline just from this configuration file. I'll show you a demo for how to do this. So let's try to create another build pipeline. I'll open it in a new window. I'll go and create a new pipeline, and as we started with the visual representation, I'll choose the same Spring Boot application. Select. I'll continue with master. Continue, and now I come back to this YAML option. I click apply, and here the one thing that asks me for is where is your YAML file path. Give me the YAML, and I'll do the rest for you. I'll give it the YAML file from my source code repository. And from here, just click Save and Queue. And it will run that configuration from this CI pipeline. You see here, we don't have any tasks as we did before, because those tasks are exported, and that it will retrieve those tasks from this YAML file. So it started running that CI pipeline, and we can see here the progress of running that pipeline. And it will run exactly the same tasks as we did before. So this is for creating the CI pipeline. We can create them visually with adding new tasks, or we can use this YAML configuration files. Now let's move to the CD pipeline. From the CD pipeline, what we want to do is to get that to get that jar file from the artifact and deploy it into an application server. Here, I'll deploy to Azure Web App. So the way to do that, I'll come back here and go to release. So we'll create a new release. We have here already some releases that they have already created, but let's create a new release. From here, it asks me it provides me some templates for doing some deployment tasks. The first option here is deploying an application into Azure App Service. Then it gives me another template for deploying a Node.js application, for deploying Python, and also it gives me a template for deploying Kubernetes into a Kubernetes cluster, whether it is AKS, Azure Kubernetes Service, or any other Kubernetes cluster that might be even in other cloud providers. We have many other options like deploying for Azure Service Fabric, for example, deploying to a virtual machine, deploying Azure Functions, deploying Go application. If you use Helm to deploy into your Kubernetes, then you have the option available here. And we can, of course, deploy for .NET developers. We can deploy into IaaS site with a database that lives inside the virtual machine. So we have those different options. Here I have a Java application. I want to deploy it into an Azure App Service web app. So I select this first template. Here I call my environment production. We'll go and deploy to production directly. And here we have another thing to configure, which is the artifact. Because the CD pipeline, the way it works, it should get a package, then deploy it. So it needs to get that package from an artifact. Here, our artifact will be the one generated by the build pipeline. For that, here I select the build, and I select my project from where to get this the jar file that we have uploaded earlier. But notice we have some other different interesting options, like using Azure repo itself, but we can also get some artifacts from GitHub, and we can get artifacts from Azure Container Registry or Docker Hub. For the case of container applications, we won't publish those Docker images into an artifact, but we want to publish them into a Docker registry. For that, here we can use either the registry provided by Azure or the one used by Docker Hub. We can also integrate with Jenkins and TeamCity. We can create the CI pipelines using Jenkins or TeamCity, and the CD pipeline, we can create it through Azure DevOps. We have a good integration between those different tools, so that Azure DevOps will get the artifacts generated by Jenkins, and it will deploy them into Azure. Here we get the artifact from the build pipeline. Oh, I should click OK. Let's select the project. Then click Add to configure this artifact. Then from here, for my production environment, I have one generated task. Now to configure this task, here what I want to do is to deploy the jar file into Azure. So first thing to do is to connect to my Azure account. For that here, it asks me for my Azure subscription. Here it can get all my subscriptions, because at first time I did have a button that says connect. I click on it and I enter my login and password for my Azure subscription. And from there, it will be able to connect to my Azure subscription to get all the services that I have, and it will be able to use the Azure CLI to deploy to my subscription. This task was configured to publish into app service. And with app service, we have different options. Maybe I have a web app that runs on Windows or on Linux, but maybe also I have a container that runs on app service. If I have a function, then we have the option for it, whether it is on Linux or on Windows. And I might also deploy an API app or a mobile app inside app service. I have Java app, I want to deploy it, maybe on web app on Linux. So I'll select that. And now here for the app service name, it will go connect to my Azure subscription. It will fetch all the Azure app services that I have created. And that uses the web app for Linux. Here it gets one, which is the Ignite Java Spring Boot, this application. If I go to my Azure subscription, you can see that I already created this web app into my Azure subscription. It is an app service, so you can see that right here. And this app service uses the runtime Java 8. So from here, we have the different runtimes supported by Azure App Service. So I configure it to connect to that app service and to deploy to that exact same app service. Then we can configure the agent. Again, here we can choose whether agent we want to use. Here, the requirement for this agent is to have the Azure CLI installed. And almost all of those agents, they have Azure CLI installed, so I can use whatever agent I want here. I'll continue with hosted Ubuntu, for example. And that's all. Now for the CD pipeline itself, this will go to deploy into Azure App Service. So here it takes my Azure subscription. It will deploy into web app on Linux. It will take the exact service. And here it expects that I want to deploy a zip file. But here I have a jar file, so I'll just go and change that by clicking right here on this button. So this will display the content of the artifact for me, what I have uploaded for the artifact. So we have uploaded the code coverage, but we have also uploaded the jar file inside this target folder. So this is the package for my application. I want to deploy this jar file. So I copy it, I click OK, and then it will take this jar file and deploy it into Azure. We have some other different options here, like, for example, specifying the application and configuration settings. For app settings here, I might change the pom.xml file. I might change some values, or for the case of .NET application, I may change the app settings.json to change, for example, the connection string. To put the connection string I use for development is not the same one I use for test or for production, so I can change that content from here. So this is all for deploying a Java application into Azure. Now we are ready. I'll go and save this. Then I'll go and release. So this will run the pipeline for me. Click Create. It gives me the link to see the progress of running the CD pipeline. If I click on logs, I will be able to see the logs. It looks for an available agent. It found one. It is trying to connect, and it will pass the script that runs those commands. It started running on the agent. This will take just some seconds. While it is running, one remark here, everything we can do from here, in fact, everything we can do with PowerShell, we can add it here. Okay, we have as we can add a PowerShell task, we can add PowerShell scripts and run them from here. So if you see that you have some requirements to do with PowerShell, you can do that here through PowerShell scripts. Now the CD ran it successfully in 32 seconds. If I click on the task that will deploy to Azure, it will display here the app service application URL, where it did display published the application. So it published it onto this URL. Command plus to open that URL into a new window. And this will go, you see that here it is published into Azure App Service as Azure Websites. And here it displays the message we saw earlier, greetings from Spring Boot. So it was that easy to deploy a Java application into Azure. So this is for the case of Java application. Now let's move to .NET. For .NET, I'll have another application, and we'll have here some more cases. Let me start with this. Yeah, I'll have an ASP.NET Core application. It's an FBC application. It has a database. For that, we see here a folder for the database. And we have a third project for the unit tests, where I have written the unit tests for my application. And we have a fourth project for Azure Resource Group deployments. This will use the ARM template in order to create the infrastructure inside Azure. What that looks like. So if we see here, the JSON file, this is the ARM template. When we deploy this into Azure, Azure will run this file, and it will create the resources described there. So from here, we'll tell Azure to create the following resources. It will create here a SQL Azure instance. And we have all the configuration for that instance, like the name. Here I'm using a parameter defined in another parameters file, where you see here we have the login for the database, the password, the name of the website, and the name for my SQL Server instance. So it will create this SQL Azure instance with all the configuration it needs to do. And it will do the same thing for my web app. So here I'm telling it to create a to create a web app. And also in this same configuration, I'm telling it to create a database. And I'm also telling it to connect my web app to that database. And the way we can do that here is by creating the connection string. So for SQL Server connection strings used in ASP.NET Core, the connection string have a specific format. And the connection string, we need mainly three or four options. We need the URL or the IP address for my database. For that here, I'm using this. So I'm saying data source equal TCP, and then here I'll use Azure to give me the URL of my database of the Azure SQL Server instance. So I get that value through here, fully qualified domain name. Then I'm still using the 1433 port number for SQL Server. Then for the catalog, I need the name for my database name. And they have created that already as a parameter. So I'll use the parameter created in the parameters file. Then for the user, I need the ID. Here I need the administrator login provided also in the parameters file. Then I need the password, and I have also created that password right there. We'll have different options for saving the password. We'll explore them later. We can get those passwords from Azure Key Vault, actually, by integrating Azure Key Vault to our to this ARM template. So now we want to deploy this application with database and run unit tests, run the ARM template to create the infrastructure. And also we have some UI tests. Here, if I go to this same application on GitHub, you can find we have some unit tests, UI tests written in Selenium. So we'll see how we can run this application. So let's start by the CI pipeline. Here I have already created the CI pipeline. And first thing you can notice here is that I have different stages for my pipelines. I have a stage for building the web app, and I have another stage for building the database, for the infrastructure, and for my UI tests. Why this could be important to run the pipeline faster, because those different stages will run in parallel. With Azure, you can run up to, with Azure DevOps, you can run up to 10 agents in parallel if you are using the free tier and if you have open source project. But of course, you can go more than that. So those will run in parallel. And second reason, maybe I have different requirements for each of those stages. Here I have .NET Core, so I need an agent that have .NET Core. All the agents have .NET Core installed, but maybe in the database project here, this database project uses the SSDT tools. This is the most used by the DBA. It's the type of project when you go to Visual Studio, create new project, and you choose database project. This project could only be compiled and built using .NET Framework. We cannot compile it with .NET Core. For that, here we can only run .NET Framework on Windows machine. So here I need to say this pipeline needs to run inside an agent that is installed on a Windows machine. Okay, so I might have different requirements for the pipelines. So with the first stage, we'll build the web app. Here I have a .NET Core application, so I start with running .NET CLI tools with .NET Restore to get all the NuGet packages I need. And then I run .NET Build. I give it the csproj so that it can generate the DLLs for my application. Then I run .NET Test and give it where to find my unit test project. Then I run .NET Publish to put all the DLLs inside a zip folder so that my package will be one single zip file that contains all the DLL files instead of my package having multiple DLL files. Then, of course, I'll go and publish this zip folder into the artifact. I'll do the same for the database. I'll go and build the database project. And with building this project, this will generate the DAC pack. The DAC pack is the file that contains the new schema for my database. When I want to deploy a new schema to my SQL server, I will deploy this DAC pack. It will compare the schema inside it to the schema in the SQL Azure. So it will apply the differences. If I have added a new column or I have changed the name of the columns, it will apply only the diff. So the result of building this project is it will give me this DAC pack file. So I'll go and publish this DAC pack file into the artifact. For my ARM template, those are JSON files. I don't need to do anything for them. Just I'll copy them to the artifact. And I'll do the same also for the UI tests. I'll build my Selenium application using .NET Framework. Then I'll publish the DLL into the artifact. Because here you notice that here we are running the unit test from here. But for the UI tests, we want to run them from the CD pipeline, not from the CI pipeline. Because the UI tests, they will launch the application, the URL of my application. And I'm sure that it will be published during the CD pipeline, not the CI pipeline. So this is for the CI pipeline. We can now go and queue it to run it. Let's open the console that will show me those. So here we see those different 4 stages. They will run in parallel. They will start in a moment while it is looking for 4. It will provision 4 agents to run those different pipelines. And here it starts 3, and we can see the progress of each one of those separately. So it will run those different pipelines, and you see here the execution is now faster than as with using one single agent. So with this, we'll generate the different artifacts that we'll need later for deploying the application into Azure. Here I move it to the CD pipeline, to the release. And from here, maybe I want to start with deploying the infrastructure. So with using this task, I'll connect to Azure, and I will give it the JSON file, my ARM template, to create the infrastructure, to create the web app, and also to create the SQL Azure, and connect and create the database file and connect my web app into the database. Here I just started by validating that ARM template because it's a JSON file, so it might contain some invalid syntax. Then I'll deploy that ARM template. After deploying this ARM template, now I'm sure I have the three resources created on Azure: the web app, the database, and the SQL Server. For that, I start deploying the zip file or the package into the created web app. I'll do that by using the task we used before to deploy Java application, which is Azure App Service Deploy. Here, it's the same configuration. I'll give it the zip file, and I'll tell it to deploy it into this web app. Now we'll deploy the new schema for my database. From here, I'll go and deploy that DACPack file. So I need to give it the DACPack file. And with this DACPack file, it will connect to my SQL Azure instance, and it will run this DACPack file to apply the new changes to my database schema. You notice here that for the password, so I need to connect to this SQL Azure instance through the login and through the password. And here I have created, for the password, you notice that here it's not in plain text, but I'm using this environment or this variable. This variable, call it database.password, we're defined in this section here, variables. I have here database.password. And here I'm doing something that is not cool at all and not secure at all, because I'm writing the password for my database in plain text right here, so that all of my developers will be able to see this this value. This is not good for security reasons, so we have here two options. We can hide that value. We can hide that value by clicking here on change variable type to secret. Clicking this icon will hide that variable, and it doesn't have an unlock feature. So when you hide it, you won't be able to retrieve it later. And we have a second, more secure option, which is using Azure Key Vault. So we can create Azure Key Vault resource in Azure, and we can create a key value to say this is my database password. And from Azure DevOps, we can retrieve this value from Azure Key Vault. And this is interesting because you can use that same Azure Key Vault to give the database to your Azure resource, to some other resources for your, maybe you need them from your container, for example, or from your web app, or from other applications. So you can share it on only one place, which is your Azure Key Vault. Coming back to our pipeline, so we have deployed the web app, we have deployed the SQL Azure. Now we have our application is running, so it's time to run some UI tests against our application. And here I go and run Selenium UI tests through using this VS test task. So this will look for my application URL. For that, here I have used this environment variable to say to tell it where to find my application. So I have created this environment variable that will retrieve my application URL. So Selenium will run. So this will make sure that my application is validated for some features. Then maybe I want to run some load testing. Here I run this task, quick web performance load testing. This will simulate that I have 250 users will connect to my application in just 60 seconds. And this will give me results for the performance. So this is our CD pipeline to deploy the web app, to create the infrastructure, deploy the web app, deploy the new schema for the database, run UI tests, then run load tests.
This is just a connection test, no actual doing things on the page.
Yeah, it's like pinging the web app. Let's now go to another feature, which is here. What we saw with the pipeline we saw is just one environment. So we might have dev, test, and production environment. And we might configure those different environments depending on what we need. The things that might change from one environment to another is, for example, to reduce the cost, we might change the SQL Azure offer we use. So we might use premium on production, but in dev environment, I don't need that premium SQL Azure. Maybe standard is enough for me. So those are the kind of things that might change. Also, the connection strings might change, and lots of configurations might change. So here we have multiple environments. We can configure them independently. Here we have another cool feature in Azure Pipelines, which is the pre-deployment conditions. What I'm telling here is that when the dev environment runs successfully, it will go and trigger the test environment. But when the test environment runs successfully, maybe I don't want to deploy directly to production environment. Maybe I need to run some or to have some manual tests, or maybe I need to wait for the marketing department to tell me when to deploy the new features. So for that, we have this feature, pre-deployment conditions, where here we can add manual approval to say this user, we can add them by email, will receive an email in each time we need to deploy to production. And it will deploy to production only when that user go and click a button on Azure DevOps to say deploy. And of course, he can refuse to deploy. It will deploy automatically if we have timeout of 13 days or 13 minutes or whatever. Great. So this is the CD pipeline for this web app. Let's move to another pipeline now for mobile applications. So we saw the case for Java application, .NET applications, and both of them are web applications. Now what about mobile applications? I'm working on Android application or iOS app, and I want to create the CI/CD pipelines for it. So first thing to understand here is that with Azure Pipelines, we can create the pipelines for Android and iOS applications if they are using native Java, Android with Java, or iOS with Swift, or also if they are using Xamarin. Xamarin is the Microsoft platform to create cross-platform applications that runs on iOS and Android using C#. Here I have created a sample pipeline for Android application that uses Xamarin. This pipeline will start by getting the source code from GitHub. Then it will start by restoring the NuGet packages. Then here, the main task is building the Xamarin Android project. This will generate the APK file. So I need to give it the csproj, and it will generate the APK for me. With the Android application, we need to sign the APK to be able to deploy it into our mobile devices. That's what I'm doing from this task right here. I'm signing and aligning the APK. So this will generate an APK that could be deployed. And that's going to be my package that I will deploy later. You see some interesting stuff here. I'm using Sonar Cloud to run a static analysis for my application. And here I'm integrating with Sonar Cloud. Sonar Cloud is the cloud offer for Sonar Cube. You can use both. You can use Sonar Cube, so you need to install your own Sonar Cube dependencies. But here I'm using Sonar Cloud, and with this, when it runs the analysis, it will publish them. It will publish them into the Sonar Cloud account. This means it will publish them right here. So I can see the results of the analysis from my Sonar Cloud account. This is the integration of Azure Pipelines with Sonar. So that will run the Sonar Cloud analysis. That's my CI pipeline. Now for my CD pipeline, I will connect to my artifact. I will get that APK, which is the package for my Android application. And maybe I want to deploy that APK into Google Play, if I want to deploy to Android or to Apple App Store. And I also can deploy to my private set of users. I can use Google Play beta or alpha features to deploy to my beta testers. I can create a list of beta testers, and I can only send my APK to those beta testers before deploying it into publicly into the store. And I also can use App Center to deploy also to another set of beta testers. App Center, it's the equivalent of Azure Pipelines, but for mobile applications. This supports, you see for the different features displayed here, it can do the build, the test, and distribute. For the build, it can generate the different APK and API for Android and iOS, whether it is Xamarin or native or React Native application or Ionic application. It supports all of those frameworks. We can also run tests. Those could be UI tests that runs on our mobile application. And we can also use this feature for distribute. Distribute will create, as we see here, different set of groups. I have here beta testers and I have intern testers. So we can choose the APK will be sent to which one of those groups. Those testers will receive an email with a link. They click that link. It will guide them on how to install the APK on their mobile devices. On iOS, this uses test flight. So I'll do that here. So I need to connect to App Center. And here we have integration with Azure Pipelines and App Center. Then if I have some UI tests that I might write them using Xamarin UI framework or using Appium. Appium is the mobile version of Selenium. So we can run those UI tests as well from here. 2 minutes left. Let's now move to the last demo for deploying into a Dockerized application into Kubernetes. So with Docker here, we have a pipeline for building and publishing a Docker container. So the first task here, build an image. This will perform Docker build. Then it needs to get the Docker file. For that here, we are providing that Docker file right here. We are telling it to look for any file called Docker file with those double asterisks. And when it generates an image, we won't give it a name. Here, we are specifying the name for this container image. We create the image, then we'll perform Docker push in order to push that image into Docker Hub or into Azure Container Registry. This is the way we publish the artifact of a Docker container. We'll push it into a registry, into a container registry, rather than into the artifact folder. Then we might run some replace tokens task. For example, when we deploy to Kubernetes, we have those YAML manifest files, and they contain the name of my new created container. And the new created container will have a new tag, the equivalent of the version. And each time we need to update that tag. So I might do that with this task, to look for that tag and update it. Then we'll upload those YAML files into the artifact folder. After that, from the CD, we'll take those YAML files and we'll deploy them into Azure Kubernetes service. We can deploy to whatever Kubernetes cluster that could run on Azure or another cloud provider or your own Kubernetes agent, Kubernetes cluster. I have pushed the image into Docker Hub. For that here, on my Docker Hub account, we can see that we have the latest image on this repository. And from the CD pipeline, I'll be able to retrieve it from here. The YAML files will reference that Docker container from my Docker Hub account. Before my last slide, we have what we call the marketplace for Azure DevOps, where we have different tasks. So from here, those tasks are created by Microsoft or by third-party contributors. They have created different tasks for different needs. So if you are inside Azure Pipelines, you are looking for a task to perform some specific build actions and you don't see that, from here you can see, you can browse the marketplace to find the task you want. So we have, as you see, we have here different tasks built by the community. So this was it for my presentation. Thank you for coming. And if you have more questions, I'll be on the hub area at the demo stations all the day, today and tomorrow. If you have questions, please come and ask me. And finally, thank you for coming to my session.